Hello everybody and welcome back to the Building Design Fundamentals video series. Today we're going to talk about grids. If you remember back to the original video, we did not model the grid. The grid was actually a DXF import and was used as a reference document. And today we're going to talk about the different types of native grid functionality within the Building 3D design application. In order to do that, we're going to model phase 2 of this large building complex. We've already modeled the levels and distributed them into a grid part. We created this product structure with the automatic creation from Excel spreadsheet functionality, and we've made a first pass at modeling the overall design surfaces in our envelope driver. So we'll start with the grid by launching the reference planes grid from table command, and it brings up this dialog box where we can control the planes that we'll be using as input, where this grid is going to be created. We can set the origin of the grid, so the location where the intersection of direction 1 and direction 2, or first direction, second direction, will be located. Those two directions are alpha and then numeric. We can set what's going to be a primary grid line or a secondary grid line, and control the spacing between the grid lines and whether those grid lines are going to be referenced to the previous grid line or from the initial grid line. If you want to add a new grid line, you can do that by clicking on the Add Above or Add Below line. And if you want to add multiples, you can just select in the dialog box the number of lines that you want to create. Let's add a few more in the first direction. I know the spacing should be set to 4 meters for these grid lines, but I'm going to intentionally leave them at 3 just to show an additional functionality. If you would like to control the overall spacing of individual grid lines, you can do this via Excel with this link here. Click on the Excel button. It's going to launch the table and give you access to grid names, grid distances, and different offset parameters where you can control it in Excel, save and close Excel, and you'll see that the dialog box and all of the associated parameters have updated. And that's a very quick, non-exhaustive overview of the reference planes grid by table overview. It automatically does create the labels for you. And in this case, I'm going to make them a little larger so they're easier to see. I could have done a select of these labels in the tree, and that might have gone a little faster, but instead I clicked one by one. Then do a multi-edit, and we'll change the size of the display font here to 1500. What you see is what you get in terms of the size of these grid labels. In order to see this a little better, I'm going to go into my preferences and change the Z buffer visibility setting. And that's in Common Preferences, 2D, 3D View Display, Visualization. Another way to create a grid is with a sketch and your level planes, and that's called the reference planes grid. So let's create a sketch. We'll do that with a couple of lines, and this sketch is going to be for this curved area of the building. Again, I'm not going to be very precise or nearly as precise as I should be when I create this grid. Normally, this would be properly geometrically constrained with clear controls of this grid in order to be the basis for the geometry of the envelope surfaces and all the geometry that's going to be built on top of it, including any vertical circulation, horizontal circulation, interior walls, structural members, etc. So the creation of this grid is critically important, but for the purposes of this video, I'm just going to very, very quickly run through the creation of this sketch geometry and then the creation of the grid. So to create this reference planes grid, it is as easy as creating a sketch with 0 output geometry, selecting all of your level planes, and Building 3D Design is going to automatically project that sketch onto all of those planes and create that 3D skeleton geometry of the sketch itself. Within the reference planes grid dialog box, you have options to scale or to twist the grid as the sketch is being projected up onto each individual level plane. But in this case, we're just going to keep a simple grid. With the reference planes grid, we're going to add labels manually. Once we input the first label, Building 3D Design is going to remember the previous label and then iterate through if it finds an integer within that label name. In this case, we labeled the first label P1, and Building 3D Design is going to iterate now P2, P3, P4 automatically. So we create all of our labels, and we're going to hide the labels on the opposite side because we don't need to see those. We don't need to keep them visible. And then we're going to go back to the labels on the front side and just extend them out a little bit so that we don't have overlapping labels. So again, we'll select them all, multi-edit, and just extend the extension line out a bit further so that there's no overlapping labels. By default, the grids are going to be visible on the lowest level that you've selected as input to create the grids. But there's another nice thing about the way the grids are visualized depending on your orientation. So if you select a face and go normal to that face, where you position yourself perpendicular to the grid, you see that the grid visibility will then flip to be parallel to the view or perpendicular to the view, depending on your perspective or orientation. Similarly, for the other side of the view of the other side of the grid, going parallel to that view plane is going to give you the visibility of the grid along that view. It's important to note that this is only the case with the grids by table. The reference plane's grid by table, or the visibility settings are not going to change for the simple reference planes grid that is created with a sketch. The last thing I want to highlight here are some visibility settings. You can control the visibility of the grid line labels in 3D by selecting that option in the pop-up menu, and then hide them again by deselecting that button. The last thing I want to talk about is grid output. So with the grid output functionality, you can output geometry, lines, curves, arcs, points, or axis systems from the grid and use that geometry to build other geometry. You can use the output lines for walls, you can use the points for stairs, you can use the axis systems for other geometry. All of that is also going to be adaptive and associative to the grid. So it's going to output this geometry, and you'll see it here in the tree. It's going to be output into specific geometrical set, and it's going to update with the grid. So if you need to make dimensional changes to the grid, so you want to change the spacing between grid lines, the geometry that's output using the grid output feature is going to track those changes and update accordingly. So if a grid line moves, the line that's output from the grid is going to move, the point is going to move, the axis system is going to move. All of that geometry remains associative to the grid and can be used for all sorts of CATIA modeling operations downstream. It's also important to note that there are a number of accelerators that can speed up the grid output geometry creation. These are the same accelerators that you'll find in the civil structures design application when you're creating concrete or steel beams or columns. So that's a very quick overview of the native grid functionality in the Building 3D design application. You have the same functionality in the civil structures design application that I mentioned just previously. I hope you enjoyed this video. I hope you get something out of it, and I can't wait to see some of the fantastic things that you do with the Building 3D design application in the building designer and building design engineer role. Thank you so much for watching, and I'll see you in the next video.